Good morning, sir.
Good morning, sir.
Yeah, good morning, everyone.
Good morning, sir.
So, I hope all of you had a nice exam experience yesterday.
Yes, sir. Yes, sir.
Yes, sir.
Okay, okay. So, yeah, I think there was uneven performance. So, there could be many reasons, personal reasons for that. Also, I don't know how many of you also used idle to help with you during the test. How many of you used idle during the test? Let's put it to a poll. Let's see how many of you will be honest here, isn't it? So let me just start a poll. I just want to find out. Let's see. What do I want to find out? How many of you used idle, isn't it? 1 second. Let me just do that. How many of you used idle for help during yesterday's test? Right? So, yes, no, that's it. So I'll just launch it. And I'll show everyone the live results as well. Okay. So all of you go ahead and vote. Just be honest, isn't it? So I don't think I expressly said that you should not use idle. So you can feel free and vote for this, because I think it is also, I don't see how most of you would have got this right without using a little bit of idle, isn't it? Okay, there were some tough choices and options in some of the questions. So without using idle, I think it might not have been possible, isn't it? Or I hope no one used Google or something, because that is strictly off limits. You're not supposed to use Google, and that was I had specified that in the honor code itself. But idle, I don't know, isn't it? Because some questions, some options, you have to try it out. At least if you tried it out and found all the right options, then that would have been fine, isn't it? So that is why there's no partial credit for any question. Okay, so even though you may get some option right and some options wrong, unless the question you got all the right options and none of the wrong options, the question will be marked wrong. So there's no partial credit for the questions. So that's how as I said in the beginning, in the instructions itself, mark all the right answers. Okay, so there's no partial credit. Okay, and the answers, we can maybe with idle it is easy to figure out all the answers. You don't really need my help in the answers, because these are just very short questions. You can just put it in idle and find out the answer itself. I can tell you, if there are any concerns about any answer, please raise it in the classroom. That we'll discuss. I'll also try to provide a quick summary of the answers. But all of you should be able to work out the answers of the test. Now that the test is over, isn't it? It's really, not anything to use idle and find the answers. No, you're not within a time frame or anything. You can do all the options at the idle and find out which are the right options. So, so all of you at least find out the answers. Don't wait for me. Okay, we'll have a short discussion tomorrow on the answers. Okay, make sure before that you know all the answers yourselves. All right. So, is there any other comments? Anything you want to share with me regarding the test? Anyone?
Hi, sir.
Yes.
Yeah. Sir, actually, we were thinking like if you could share some questions like these, these are very tricky questions. So if you could share questions like these before the exam, like as a practice one, periodically we would be like challenging, you would be giving us a small assignments like this, and then we would be like, we have to figure it out and something like that.
You were provided some sample questions on Sunday evening. These are
Yes,
not
sir.
really, I mean, these are not, there's no trick in the questions. I don't see what is the trick. It's just,
No,
you
no,
just
no.
have to select all the options, that is all. See,
Okay,
I can
sir.
understand that, yeah, I mean, this is just your first test. None of you have to, sort of panic or anything, because we only have, we have some best of 5 or something like that. Okay. I think we have 6 assessments plus 1 assignment, and we'll have best of 4 out of 6. And the 1 assignment will be a mandatory assignment. So we have best of 4 out of 6 assignments, quiz assignments. So you have a lot of choice still, okay? And we can consider this as a, and still these are just 25% of your internal, of your grade, okay? The internal assessment for the online mode is only 25%. The external assessment, the final exam is 75%, okay? It's usually 50%, 50% if you are on campus, okay? Since we are doing it online and the online mode has its uncertainties, as I said, it's also apparent from the poll, isn't it? Some of you used IDLE, some of you didn't. Some of you may have used Google. I can't prevent that. I can only say there's an honor code, and I hope that all of you stand by that, okay? So there's no way to actually, invigilate or anything, hasn't it? So, and you've been given ample time for the test. So I think it's all like fine in the final thing. And I should also add that, those of you who are, who are trying to work it out, each of these questions, that is useful for you in the longer run. Okay, it will be definitely useful for you in the end semester, because in the end semester we're not going to do this like you have access to all the materials, and that is not going to be there. So you really have to have experience programming, and what you do now will really help you at that time. All right. So and moreover, the end semester is the bulk of your grade. These are just 5 marks at the most, and moreover, we have best of 4 out of 6. So I don't think anyone should get this is the little things. I don't think you should really sort of let it impede our progress in the class. All right. So okay. So I think these are. I framed these questions. These questions take a lot of time. These questions I framed so that they help you in the longer run as well. When you appear for interviews, let's say they give you a Python quiz, okay? So I'm sure some of you who have done a BTech and attended these IT interviews. I don't know how you compare the test with these interviews, but I try to make this so that you also get, this is also job oriented, and you get some practice for these tests in the end, okay? So only if you are really solving this, you'll be able to approach those particular tests. If you're again doing some
sorry to interrupt, sir.
Yes.
Sir, you told like a semester, no, sir, Python exam for semester. Will it be like we have to write the codes, or will it be theoretical?
You mean the end semester exam?
Yes, sir. Yes, sir.
End semester exam, as I say, my courses, they are entirely about all about coding. Okay, so I'll ask you to write functions. I'll give you some problem statements. I may also give you some code myself, and I'll ask you what the code does.
Okay, sir.
Okay. Yeah. So theory questions, I don't see much point in a programming course where we want to develop the computational thinking. Okay, the data science and the Python, isn't it? Okay, so I keep my objectives very clear. I really want you guys to learn this practical material. So theory questions is not going to help. Okay, when I ask this sort of questions, you apply the theory. So the theory is a prerequisite to doing this, isn't it? You must have the practice. That is the final skill. Okay, so we know so many professions. We have these professions because you know the skill. So the theory is not going to give you the programming skill, the coding skill, the thinking skill. So it is part and parcel of everything, but finally you have to apply it. So the end semester will be entirely applied.
Sorry to interrupt, sir. Sir, actually, that was I was suggesting that only, if you could share more questions like these, like apart from the quizzes, so we would be also like okay challenged to try this out, and like most of us would be doing that preparing for interviews also. So like that, we would also get the exposure of answering questions like that.
Yeah, you've done one test, so I think there should be exposure enough. So I can't, sort of give you job interview questions during this course because I have a bigger responsibility. I have 58 students who are in this class, for whom the first objective is to learn Python, and I want to impart some computational thinking. Your jobs happen like 2 years down the line. I hope I'm helping you in that direction, but this is not a training program for the jobs. Now, I have already sent you something in the classroom regarding these questions. I posted sample questions, okay? And we're doing enough things in the class. We don't, this is just a 3-credit course, okay? So I hope all of you keep that in mind. I'm trying to pack as much as I can in the 3-credit course. What I'm trying to tell you is that, okay, don't panic with these assessments, okay? It's just 25% of your grade. Every single assessment is in fact carries just 5 marks towards the final 100. And even in that, you only have best of 4 out of 6. Okay. So, all right, let's get on with the class. Now, I want to give you another short background about OOP. Okay. And then we are going to do a demo as well in the class. We're going to do it with idle. So keep your idle open. Okay, so we are going to actually write the first class today. Okay, so we'll be writing our first class today. All right. So okay, so what is this? So we have seen about the objects in the last class. Okay, and we saw these objects enable us to define a behavior. Okay, that lets us use a particular data type. Okay, with some methods associated with the data type. Okay, we can define our own data types and our own methods to go with the data type. Just like we have a list data type and we have many list methods. Okay, so similarly, we can have any sort of a object that we would like to use in the current problem. We can define a class for the object and define our own methods to go with that class. Okay, and in that way, we now have a new class that we can use in that particular problem as well as any other problems in which this class will be useful. It's just like writing a function that will be useful in many different places. We can create our own classes. So that is the power of OOP. So we can bundle together objects that share common attributes with the procedures of functions, that is the methods that operate on these attributes. Okay, and we can use this abstraction to isolate the use of the object from the internal details of the object. So as coders, we will be doing the internal representation of the object, and those who want to use the classes later on, isn't it? So the end user need not know the internal representation of the object. They only need to know what are the attributes and the methods that they can use with the object. And that is the interface that is provided to the end user. Like we are now using Python, we use list and all its methods like append, extend, and all these different things. We don't know really how these are implemented in the Python language. All we have to know is we have access to a list class. We can create list objects, and for each of these list objects, we have a set of methods that we can use with the list object. So we isolate the use of the object from the details of how they are constructed, isn't it? Like this, we can build layers of these abstractions, okay? And we can also use inheritance, okay, to simplify the way in which we code these particular classes. And we'll be seeing inheritance as well a little bit later, okay? So essentially, we can create our own classes on top of the Python's basic classes. So every data type, everything we have seen as a class, and we also have the facility to create our own classes in Python, and we'll be creating our first class today. All right. So how do we create a new class? So just like we use the def statement to write a new function, we use the class statement to define a new type. Okay, that is when you say class, isn't it? It's an object, isn't it? So the object has a type of that particular class. When you create a list, it is of type list. So list is the class and the instances are of type list. So the class statement is basically used to define a new type, a new class. Okay, and so you say class, just like you say def and function name, we say class and the class name. Okay, so what is the data type name? Coordinate. And then when you don't have any parameters to pass, we'll come to this shortly. It is the base from which it base from which the argument is given, and we just say of object. Okay, and then we define the attributes here. Okay, and we'll see how to write the code for the class. Okay, all we are now doing is see how to declare a class. So class is the keyword, and the statement goes like class and class name. Okay, of, and we can give some parameters here based on which objects, which classes it is inheriting from. So we'll come to that later. So till we do inheritance, it is not inheriting from any other class. So that means it is just a object. So we just say object, which is the base class. Okay. So it is a of the base class. So we just say object here. So now after the class, you put a colon here, and then you indent the code to bring in the code block that belongs to the class. So this is just like what we did with the def. We say def and function name, and then we give some parameters, and when we put a colon and we indent and we give the code, isn't it? So these are the statements that are part of the class definition. All right. So here I also want to remark. Now I know. So with respect to the test, you see the test we are doing is a assessment test, isn't it? Okay, but in the end semester, you're not going to have this multiple choice or fill in the blanks or any of these things. We're going to have functions and all these different things. Okay, so that will be a place where the majority of what we are learning, the sort of learning we are trying to accomplish. Now I'm trying to mix both. Okay, both your job interview and the actual Python learning. But this sort of experience that we get from actual programming, it is very important in the end semester exam, because you'll be asked to write functions. There'll be proper problems that you're required to solve. Okay, so all right, so we say def function name parameters colon, and then we give the code block, and then so it's similar in structure to that. Okay, so it can inherit attributes from other classes. So here it only inherits from the base object class. Okay, so there's no superclass or to which it belongs. So it is just said to be a subclass of the base object, but the object is supposed to be a superclass of the coordinate. Okay, so this is a terminology. And all right, so let's see how to actually do the class definition now. All right, so we have to initialize the class. So anyone who has done some object-oriented programming, we took a poll, isn't it? So I think more than half of you have done some OOP, and there are also many of you who have not, done a single OOP program, isn't it? So pay more attention. We have to first construct the class. Okay, whenever we define a class, we have to initialize the class. So the first part of code that we write is called the code initialization. And in Python, there is a specific way to initialize the code, and that is called the _init method. All right. So this is the _init, and what we do here is all the code that we write under the class, okay, are given as functions. Okay, but in the context of the class, they are known as methods. Okay, so each of these methods, okay, if they did not belong to a particular class, they'll be called as functions. Since they are methods, since they are functions associated with a given class, they're known as methods. So methods are nevertheless functions. So they are defined by using the def keyword, just like we define functions. So you have to say def and what is the function method name, and then what are the parameters for the function. Okay, and then we write the method code here. All right. So for initializing the class, the method is known as init. So we say def _init of self, x, y. Now, self is the argument that we use to specify to the object itself. That is the object. This is a method of the object, and self refers to the object itself. And x and y are the actual parameters for the class. And here we initialize the object values to the parameters that are passed. How does this really work? So method is just another name for a function, okay, but that belongs to a class, okay. So when calling the method of object, the object is always passed as the first argument, okay. So therefore we use self as the first argument of all the methods. So whatever method we write within class, self is always the first argument, because by convention Python passes the object as the first argument. The object, we call the method on the object, and the object is passed as the first argument to the method. So that is why when we write the method definition, self, which refers to the object, okay, by convention is given as the first argument. Only then the other parameters of the function are given. Now coordinate has two parameters. What are these parameters? We're talking about a coordinate of a point in the XY plane, okay? Whereas a single number can only indicate a value in a single dimension, a coordinate, a Cartesian coordinate, will have two dimensions. So how do I represent two dimensions? Isn't it? Values in two dimensions in one number? We need a new data type, isn't it? So we need to create a new class. So that is why we are creating the coordinate class, okay? And so how many attributes does the coordinate class have? It has both the value along the x dimension as well as the value along the y dimension, okay. So that is why there are two arguments, two parameters to the coordinate. The self refers to the object itself, and therefore what we can say is we have to define the object attributes as equal to these parameters, okay. So how do we refer to the object attributes? We already know that. It is the dot operator. Whether you want to call the method or some attribute, we have to use the dot operator. You say dot x, that is the data attribute. If it's a function, it takes off parenthesis, isn't it? So we say self dot x, or it can be any other attribute, is equal to the x that we are passing here. Self dot y is equal to the argument that is passed here. All right. So this is how we do this. Okay. So now we are initializing the class. Okay, when you declare a object as coordinate object, okay, the x and y that you pass as arguments are now initialized as the object attributes. All right. Okay, so this is the basis, and this is called as constructor. This is the class constructor or initializer for the class, and this is done by using a double underscore method. So these double underscore methods are standard methods, okay, and they are known as magic methods or system methods because they have a specific meaning, okay. When you want to write a method name, never use a double underscore unless you are trying to write a magic method like this, double underscore init, okay. So these are called as double underscore methods, and they have special significance, and the init method should be present in all class definitions. Any class definition should have an init, because without the init, the class cannot be constructed. Okay, so that's why it's called a constructor or initializer, and it initializes the particular instance. Okay, so the dot operator is used to access the attribute of the object, and the init method above is defining two new attributes for the coordinate object, that is the x and the y. All right, so when accessing the attribute of an instance, we first go within the class definition. Okay, and if it inherits from a superclass, we can then go to the superclass. Otherwise, we have to go to the outside environment and see whether the attribute is present or not. So that is the hierarchy in which the information is accessed. Okay, so the data attributes of the instance are called as instance variables. Okay, so the self.x and self.y are known as instance variables. Self is the instance, okay, and .x and .y are the variables corresponding to the instance, so they are known as instance variables. All right, so now outside the class, how do I declare an object of type coordinate? All I have to say is C is equal to coordinate of, okay, and how many arguments do I pass? Two arguments, x and y. Self is the object itself. Okay, so self need not be passed because that is automatically passed by Python. Only when we define the class, we have to give the self. When we instantiate a object of the class, we just have to give the other parameters. Okay. Other than self, what are the parameters? Those have to be passed in the same order. Okay. And as you know, we can also give some keyword arguments. So we say coordinate of 3, 4. Okay. And then I give another new object, origin is equal to coordinate of 0, 0. Isn't it? So origin at 0, 0. So I can say 0, 0. Then I can print this and let's see what happens. All right. So, so this the expression, class name or values will create a new object, coordinate of 3, 4. And when it creates the new object, basically calls the init function. When you say C is equal to coordinate of 3, 4, it calls the init function and executes the code in the init function. It doesn't do with anything else in the class. It only executes the init function. So whenever you declare an object of the given class, only the init function is executed, and that is why it's called the constructor. So whenever we declare an object, what all has to be executed? That's what we put in the init function. All right. So now when I say coordinate of 3, 4, this init method is called, and these are being assigned. So once these are assigned, self is C now. When I print C.x, it will be 3. And when I say origin.x, it will be 0. Okay. So when the method is finished executing, okay, when you say coordinate of 3, 4, the constructor is executed, and when it's finished executing, Python returns the initialized object as the value, which is assigned to C, and it is assigned to origin here. Okay, so we don't have to provide the argument for self. Python will do it automatically. All right. Okay. So how do we visualize this idea? So basically, the coordinate is the class. Okay, and the class needs to be defined only once. But then you have some objects of the class. We have some instances of the class, and you can have many such instances. The class needs to be defined only once, but there can be many objects. Okay, so in this object, the class is x is 0 and y is 0. This is the origin variable. And here in this instance, the class is x is 3 and y is 4. Like that, you can have many smaller clouds, many small objects. Okay, all belonging to the class, but the class itself needs to be defined only once. Okay, so that's the idea behind class. So let's now do a hands-on for this. Okay, so that is the introduction to the classes. Okay, from here on we'll be only doing hands-on, and we'll be trying to create many classes, and we'll be defining classes with multiple methods. Okay, we'll be doing the constructor, and we'll be adding many more methods to each class that will be useful for the class in question. Okay, so let's do that. So let's go to idle. So okay, what we will do now is see exactly what we've been doing in the slides. So I'll say class coordinate. Let's define a new class of, okay, it doesn't inherit from anything. So we just say object, and let's do the constructor for the class def space double underscore init double underscore, and the first argument is the cell. Then it takes two attributes, x and y coordinate. Okay, so x comma y, and all I have to say is the self.x. Okay, the object that is calling its x variable is equal to the argument x, and self.y is equal to y. Right? This is my simple coordinate object. Okay, we'll come back and add more things here, but for now this is fine. So what we will do is we'll just run this. And we say it's a coordinate.py, and let me save this. So now it's run and it's fine. The class has been initialized. So now what I can say in my idle here, so I can say C is equal to coordinate. How do I declare a new object, isn't it? Okay. So how we create a list. Okay. So this, like, think about how do we create a list. Can anyone tell me how we create a new list?
LSP equals
list is equal to square bracket.
Good. L is equal to square bracket, isn't it? So that will initialize the list. Do you know any other way to create a new list?
L equals to list method, sir. List and parenthesis.
Good. L is equal to list of. Okay. L is equal to list of. Now what you're doing here is the class name is list. Okay. And by saying list of, you're just saying L is a object of class list. So similarly, I want to now create a new object C of class coordinate. So I say coordinate. But then here, this coordinate class takes 2 arguments. You don't have to give any arguments for list. It's just an empty list. So you don't have to give any argument for the list when you create a new list object. But when you create a new coordinate object, you have to give 2 arguments. Okay. Suppose you were not to give any arguments. Let's see what happens. Okay. So it's a type error because it's missing 2 required positional arguments. All right. So now what we have to say is, so C is equal to coordinate of 3, 4. Okay. So now I have C initialized as a coordinate object. So now I want to now I can do what is this? A dir of C. So you see it has the
equal to coordinate.
sorry.
Sir, here we'll give origin is equal to coordinate. No, sir. Origin value is 0, 0.
Yeah, we can do that. So I'm trying to explain to everyone that now you see C has these 2 attributes X and Y. By by inheriting from the base object class, it has some other methods. These are all built-in default methods for any class. But apart from that, you see it has 2 instance variables X and Y. So suppose I want to access these 2 instance variables. How do I access them? Suppose I want to access the Y. How will I access the Y?
By calling the dot method.
By calling the dot method. So this Y belongs to the C object. So I have to say C dot Y. Excellent. So now it is 4. And I can also say C dot X. All right. So now let's do the origin as one of you wanted. So we can just say origin is equal to coordinate 0, 0. And I can say print of origin dot Y, C dot X. All right. 0 and 3 are printed. Okay, excellent. So now we know how to create a new class and declare objects of the class. Okay, how to instantiate new objects of the class. Okay, so we have done both. So now what we have to do is we have to create some new methods for the class. Okay, so this is just the object definition. Okay, this is just like saying list of. Now we have an empty list. Okay, and we have created some list objects as well. Now we want to see how we can create the list methods. Okay, so we have a list and then we can do a append, we can do a extend, we can do a reverse, we can do a sort, we do many different things. Like that, I want to do some operations on my coordinate object. Okay, so what is one operation you want to do on your coordinate object? Anyone?
Calculate distance.
All right, good. So let's see. I want to now calculate distance from origin. Okay, let's say distance. Okay, distance from origin. Okay. Now, what will be the arguments to this function? Anyone?
X1, X2, Y1, Y2.
Okay, it is from origin we have specified. Okay, so the distance of this point from the origin, we're not creating a function. Okay, this is a method for the given object. The given object already has some coordinates. I want to find the distance of this object from the origin. So what will be the arguments for this function, parameters?
X and Y, sir.
Okay, you mean the objects X and Y?
Yes, sir, because we are finding the distance from their origin, no, sir.
Okay, so the object X and Y is self.x and self.y, but we don't have to pass that because anyway the first argument is always self. Okay, all we have to say is self because anyway self has to be passed. It's always the first argument in the methods. Okay, because the method is called on the object. Okay, so we have to find the distance of the object from the the origin, we only require the objects x and y coordinate. That is already there in self. Okay, so now how do I calculate the distance?
Sir, we have the formula also.
We just have to. What is the formula?
X minus of 0 the whole square. I don't remember the formula. Root of x.
But what is x here?
X is self dot x.
Good. Okay. All right. So what we have to find is self dot x minus 0 the whole square, but that is just self dot x whole square, plus self dot y whole square, isn't it? Self dot y square. All right. So this whole thing we want to have the root. This is what has to be returned, isn't it? I can just say return of this. Okay. So all right. Is that fine with everyone?
Yes, sir.
So now we just save this. All right, so now let's define some new objects. I have to again define the objects because the class definition has changed. All right, so I'll say now how do I call this method on C? Suppose I want to find the distance of C from the origin, what will I do?
So we have to call that function name also, distance from origin. Is it like that?
How will I call that method?
Coordinate dot the method name.
So I want to find for C. Okay, so what will I put here? I want to find the distance of C from the origin. C is my coordinate object, coordinate of 3, 4. I want to know its distance from origin. How will I find out? What should I give?
Sure. C dot self.
C dot
Self.
self. Why self? C is the self when you call the method.
C dot distance from origin.
Okay, good. C dot distance from origin. Because the distance from origin is a method of the object, isn't it? This is the method, and you have to call the method, isn't it? It's just like list dot append, list dot extend, isn't it? So the method name is distance from origin, and that is available to all objects of type coordinate. So I call that particular method on C. Now what do I do? It's a method, so it's like a function, so it has to have parentheses. Now what should I give within the parentheses?
So the x and y self x and y.
No, C will consist of that x and y, right?
Okay, okay.
Sir, I think nothing we should
So
do.
only self is passed here, isn't it? Okay, because these are self instance variables, they can be accessed from self. Okay, so self is anyway automatically passed by Python as the calling object. Because C, we are using the method on C. Self is already passed. Just like you see in the init, self comma x comma y, we only have to give 3 comma 4. Okay, so C is the calling object. So we're using the method on C, so automatically C is passed as self. Okay, so when C is passed as self dot x becomes C dot x, and self dot y becomes C dot y. So we just have to give nothing, no arguments, because there's only one argument self, which is the calling object, which is already there. Okay, and this is how it works. All right. So what is the distance of C from the origin? C dot distance from origin of. Okay, and gives you 5. Is that correct? Fine. Suppose I want to do this. Can anyone tell me what the result will be? A0, excellent. All right, so now we know how this method works. Now let's say I want to write another method. Okay, I want to find the distance between two coordinate objects. Okay, not from the origin, but between two objects. Okay, now here we are fixing one of the objects as the origin. But let's say I want to find the distance between the given object and some other coordinate object. Not necessarily origin, it can be any other coordinate object. Okay, so now I want to find the distance between two coordinate objects. Now, how do I do this? Okay, we just call this function as distance. Okay, let's call this method as distance. How many arguments I have to give here? What is the first argument? What is the first parameter? Anyone?
Sir, I think it's the coordinate which we are going to pass.
The first parameter is always self. Any method, first parameter is self. Okay. Now, what is the second parameter?
Yeah, the coordinates which we need to pass for the new distance which we
Correct.
are going to calculate.
Okay, the coordinates that we need to pass. But that can itself be another coordinate object. We don't have to pass the instance variables of the coordinate object. We can pass the coordinate object itself as an argument. Okay. I mean, Python, everything is a object. Okay, the instance variable is an object, the coordinate object is an object, even a function name is an object. So anything you can pass as a parameter. Okay, and so instead of giving too many arguments in the function, we can just give the coordinate object itself as a parameter, and then we can access the instance variables of the coordinate object. Okay, so this coordinate object we'll call as other. Okay, now what is the calculation I want to make?
Sir, we have to assign others, assign for others some values.
No, we don't have to assign. That will be passed. When you call the method, you are passing the other. We are only writing the function now.
Okay, sir.
Right. So what is distance? Anyone?
So the same formula, sir, which we have did for the return. I think.
Can you tell me what it is here?
Self dot x whole square.
Self dot x the whole square. This is not from the origin, it's from the other, isn't it?
Yes.
Like x minus 1, sir.
X minus 1.
It is x square minus 1.
Square minus 1. Why 1?
Because no, sorry, you said it's not from the origin, so I thought from the first value.
No, it's from the other. The other coordinate object is other. We want to find the distance between the self and the other. So the other is also a coordinate object. It's a variable for the coordinate object, isn't it? So what is the distance? Self dot x minus
Self dot x minus other, sir.
other dot x. Okay, self dot x minus other dot x, the whole square, plus what?
Self dot y minus self dot y.
Other dot y, good. Whole square. Okay, the whole of this we want to take the root. Okay, and then we return the list. You can just give it as one line, but we're just splitting it into 2 lines. So that is fine. All right. So now we have a new class definition. Let's save this. Okay. So now it is saved. So again, I'm going to do a coordinate. And then we'll have the origin as well. Okay. Now let's define another object. Let's say D is equal to coordinate of all right, and let's say E is equal to, so I can create many coordinate objects, 2, 3, and F is equal to coordinate. So this is our first class, isn't it? So you can have some fun by creating a lot of objects. All right, so you see in our object we have created a constructor which is necessary for all classes, and we have created 2 separate methods. Okay, and we have already tested out one of the methods. Now we are trying to test out the second method. All right, so let's test out the second method. So now let's say I want to find the distance between C and D. How will I find the distance between C and D? Okay, so both of them are coordinate objects. I want to find the distance between.
Sir, is it like C command D dot calling the distance?
Oh no, you think about the list. Okay, always, what I try to do is you think about the list. We are very familiar with the list and the methods of the list, isn't it? How do we access the methods of the list? You have done this many times, isn't it? Similarly, C is a coordinate object. It has a method called distance. Okay, I want to use this distance method on C and find its distance to D. How will I do that?
So C dot distance of parameters D.
Very good. C dot distance of
parameter what? D alone.
Parameter D alone. Very good.
D, sir.
Okay.
D, object D.
Object D. Very good. You see, the distance takes 2 arguments. Self. Self is already the calling object, so there's only one argument that you really need to pass, that is the other. What is the other coordinate object? The other coordinate object is D. I want to find the distance between C and D. So all I have to say is C dot distance of D. That is it. It's giving you the distance between C and D. Alright? Now suppose I want to find distance between D and C, just to check, isn't it? Is it working properly? You should get the same distance. And then C dot distance of, you will get the same distance, isn't it? Distance between C and F. Something I'm getting. C and E, isn't it? Okay. That also I'm getting. Okay. Now I can also find the distance between C and the origin using this distance method. Okay. That is C dot distance. Initially we used distance from origin, isn't it? And we didn't give any argument to that. But I can just use the distance method itself and give the second argument as the origin. Again, this will give me the same distance from the origin. Okay, so suppose I say C dot distance of origin or C dot distance from origin is the other method. You're getting something. Sorry?
Sir, you've written code a little wrong, sir. You've taken point instead of point, you've written point 2, sir.
Sorry? Yeah. Okay. All right. Yeah. All right, so all right, now so I can say C dot distance of origin, and I get 5, isn't it? Okay, and similarly I get the same thing. All right, so I can do all these things and say C dot distance of D. I'll get a slightly different value because the code is now correct. That is, the calculation is now correct. So 3.6 is the right distance, isn't it? All right. So I can also say E is equal to something and D dot distance of D. I want to find the distance of D from the origin. So D dot distance from the origin object, something I get. But I can also find the origin distance directly by using a method that is available. I don't have to declare a origin object for that. Just say D dot distance from origin method. I call that method, I get the same value. Okay. So we have written a very general purpose distance method that can find the distance between the given object and any other object. And this any other object we pass as a argument to the distance method. Okay. All right. And we can find their distances. All right. So this in a nutshell is what object-oriented programming is all about. Okay. This exercise we have done today, okay, till here, basically, captures the entire essence of object-oriented programming. Okay. How you declare the object and its instance variables. How do you write some methods for the object that uses the instance variables. Okay. And how do you access these instance variables using the dot operator here? Isn't it? And how do you declare the parameters for the methods? Okay, so all these. So this comes from function knowledge, isn't it? Okay, this is not particular to classes. The thing that is particular to classes is the dot operator. Okay, and the syntax for all these different statements. Okay, using the self as the first argument, isn't it? Always when we write the class definitions. All right. So that is essentially what class coding is all about. That is object-oriented programming is all about. Okay, what defining classes is all about. We saw a coordinate class today. Like this, there are many different classes, general classes that we can get some practice with. In the next class, we'll see how to create a time class. Okay, how to create a time class and some time objects. All right. What I would suggest when you come tomorrow is to solve the assessment questions, okay, and then come. And if there are any questions, you can post it in the classroom. We'll take it up during the class, okay. So that is one thing we will do tomorrow, okay. And then we'll start with the time class. Please review what we have done today and come for the tomorrow's class, and we'll carry on with our object-oriented programming. All right. Any questions, anyone? So is that clear? This object-oriented programming, are you able to, tie together the different elements that are going into this class definition?
Thank you, sir.
Yes, sir.
Okay. Okay. All right. Okay. So I post all the material review. Okay. Also go over the test. Any pressing questions, you please post, and we'll discuss them tomorrow. All right. So I hope all of you got your scores back. Okay, so that is the first assessment. We'll have another assessment, let's say a few more classes from now. All right. So have a nice day. Bye.
Thank you, sir.
Thank you, sir.
Yeah, bye.
Thank you, sir.